Good morning, students. I hope I am audible. Am I audible? Am I audible? Someone from you can unmute and speak to me. Is my voice okay? Are you able to listen to my voice? Maybe Ishwar Reddy, 5A9, you can unmute and speak to me. N. Ishwar Reddy, 5A9. You may unmute and speak to me or someone else, no problem. Okay, thank you. So I'm going ahead with my presentation. So yesterday we had some discussion on the variable rate and the stepper motor. So this particular 4 and 5 fifth figure is going to give you some idea on that. And maybe when the animation is going on in the fifth there itself, some built-in explanation is actually coming within. And of course, what exactly you need to do there is, in order to change the phases, you are going to play with these switches. That's what is happening, S1, S2, S3. When S1 is in on mode, these two will be in off mode. A and A dash will be in short. And S1 and S3, when they are in open mode, S2 will be in short. That time BB dash will be in short. Then when S1, S2 are in open mode, S3 will be in short. Then CC dash will be in, S1, S2 in open. Then AB will be in open and C will be in short and C will be excited. And accordingly, the indexing and that angle of index is actually depending upon the number of poles on the stator and the number of poles on the rotor. There was an expression that was trying to give you an idea, that is 360 divided by number of phases, that is 3, and the number of poles on the rotor, or the number of teeth on the rotor. That is going to confirm the step angle. When you want to reduce that particular step angle further, sometimes it may not be possible for you to accommodate more number of teeth on the rotor. So for the sake of that, instead single rotor, they are going to take the support of 3 rotors and on these 3 rotors, the number of teeth that have been accommodated are going to give us a clarification on that. Rather, that is going to contribute towards the reduction in the step angle. Okay. Now, anyway, this is actually the permanent magnet stepper motor. Here you can see alternately each and every pole that is available with the stator is getting excited, and the rotor is actually having permanent magnet. Because of that, north and south poles have been shown in the picture, and that itself has been made rotated. So once north and south poles belonging to the permanent magnet, when they are rotated, obviously the pole which has come close to that is going to be with opposite. That's what you can see over here. S is actually south pole being colored with blue. So the other pole, whatever is coming close to the south pole, is actually becoming red. Maybe the excitation is actually coming first, and then that is going to attract the like poles, and that is how the rotation is actually happening. You can see here in the third statement, it has been stated, it works on the principle of unlike poles attract each other and like poles repel each other. So this particular third point was banging in my mind while I was trying to explain even the other aspects, because same is the concept that is going to happen with the magnets. Magnetic aspects, maybe electromagnetic principles might be happening, or permanent magnets that might be used in a motor. irrespective of it, unlike poles in the sense north and south poles will be attracting and south and north poles will be attracting. Because of that, the rotation is actually happening. You can see here the fourth statement is actually giving us an idea on the working of it. When the stator windings are excited with a DC supply, it produces magnetic flux and establishes the north and south poles. Means the windings which are all available on the stator are being excited. That is, once that has been excited, it is going to generate north and south pole on the stator windings. And anyway, on the rotor windings, you have got permanent magnets. Okay, so that excitation on the stator windings and permanent magnet on rotor is going to contribute towards the attraction of unlike poles and repulsion of like poles. That is actually creating a driving force for of that particular rotor to rotate. Maybe I don't know how many of you have watched really. Some time back, maybe last year or so, one motor was kept in open mode and one iron ball was kept inside. And we have noticed that this experiment was done in our college itself by our electrical faculty. Side they have opened in place of rotor. What they have tried to do was they have tried to put a metal ball because of this alternate excitation of north and south poles. That ball went on rotating internally. Okay, so that way maybe some of the things whatever we have observed physically, those things should become a solution for our understanding levels. Okay, maybe that should improve our understanding levels. Even that can be tried because that has been tried once and it can be tried again and again. There is no problem in it. Anyway, let us see what exactly is being done here. There were 4 poles, and out of them 2 opposite poles were connected through a wire. That's what has been said here. See, let us consider a 2-phase stepper motor with 2 permanent magnetic rotor poles as shown in figure. See, north pole and south pole. And the 2-phase instance, this is phase 1, AA dash. This is phase 2, BB dash. Okay. So now, maybe in the beginning, this when you have excited, south pole has formed on the stator, and opposite side you are going to see the north pole on the stator. Because of that, anyway, permanent magnet is going to have north and south poles in a particular direction. Automatically, north will get attracted towards by south. That's the reason why north and south are in line. Coming to this, here you have got south, and that particular south and north here are again on inline. So that is the reason why they were attracted, whichever the position they were earlier. Now they will try to be in line because of their force of attraction and repulsion, and they will come in line. Then in the next instance, what they have tried to do was instead AA being excited, maybe AA was excited for the first time. In the second instance, BB was excited. Because of that, you can see clearly here that the north and south poles are on this side, and south pole attracts the north and north pole attracts the south. That is going to contribute towards the rotation. Maybe in the earlier sketches, whatever has been showed, when they have been excited, they have not showed on the stator or on the rotor north and south poles. You can mark them. Maybe taking into account this particular explanation, you can mark them. Okay, so that is what has been done. So because of this, the indexing is actually step angle is going to happen by 90 degrees. Maybe if you go for 3-phase, then the step angle is going to be 45 degrees. If you go for likewise, you can go on varying the number of poles, and that is going to take care of those things. Maybe you can see here, this is with 0, this is with 90, and obviously next time what is going to happen, that is going to be in line to this, and this is going to deal with the theta 180 degrees, and this is going to be for 270. So yeah, figure 1, 2, 3, 4, 0, 90, 180, 270, and again 360 as well as 0 or 1 and the same. So with reference to these figures, explanation whatever has been given earlier, same thing actually proceeded. Now even here the calculation pertaining to the step angle was showed. How it has been showed, step angle of this 2-phase 2-pole permanent magnet rotor motor is expressed as 360 divided by number of phases and number of poles. So once that has been done, 360 divided by 4 is coming. That is how it is coming as 90. So the step size can be reduced by energizing two phases simultaneously. See, that is how it has been. Say that they are not, maybe in this particular case, when they want to regulate the step angle, when they want to manage the step angle, what the method they are trying to do was two phases are going to be excited simultaneously. Maybe this is how, say one phase on and second phase on modes with appropriate polarity. Okay. Anyway, we are not going to go in depth to that particular extent because there is a table wherein on off are going to be indicated with 1 0 1 1, and that particular one order is going to go on change, and that is how they are going to control all those regulations. But anyway, to that extent, you don't have to go in depth to that. But if someone is interested, they can definitely open some content pertaining to that, and if they are not in a position to digest the content, they can definitely approach me personally. Okay, so maybe if I am having an idea on that, I'll be able to clear that particular query immediately. Otherwise, I'll come with that particular answer with you in a short span of time. Anyway, when it comes to the hybrid stepper motor, it has been identified that it is the most popular type of motor which has been put in use. And when it comes to the performance wise, it has been observed that it is performing in a better manner than the permanent motor, magnet rotor, in terms of step resolution. Step resolution in the sense, the small step size, what is attainable with the support of a motor. And not only the step resolution, even the torque that is possible to produce, as well as the speed that can be attained. So if you consider major parameters over here as step resolution, torque, and the speed, with all those parameters, when the comparison was done with respect to the permanent magnet rotor, the hybrid stepper motor performance is always proved to be better. And of course, if you still want to go in depth beyond this, you can consider torque speed curves. They have been referred under characteristic curves. I am not going to show them to you. Let me see if time permits, because I am already actually having some delay with respect to the content being covered, lagging with respect to the content being covered with respect to the other faculty people. Maybe, I don't know what pace I can cover. That is a secondary story. There is a torque and speed curve for each and every motor. That particular curve can be plotted, and that particular curve can be used as a reference for you. Okay, so if you want, you can grab that particular content in the assignment when I give. That time you can add that particular content while submitting. And anyway, you can see the major advantage over here. It combines the best features of variable reluctance and permanent magnet. See, prior to this hybrid stepper motor, we have come across variable reluctance type and permanent magnet type. Both the features, the best features that are available with the both the varieties are being taken into account. And moreover, if you consider the step angles over here, 1.5, 1.8, and 2.5, even such a small step angles are possible to attain with the support of hybrid stepper motors. And the stator of this motor is same as that of permanent magnet or reluctance type. See, you have got rotor in both the conditions, in permanent magnet and reluctance. Whereas in permanent magnet, the rotor metal is being replaced with ferrite. That is actually can easily be okay. That is actually a material which is coming under magnet. Okay, the stator coils are wound on alternate poles. So that is obvious, because AA phase is one, BB is another phase. That is how it has been wound round. The coils of different phases are wound on each pole. Usually 2 coils at a pole. Okay, so that's what is the meaning over there. Anyway, if you consider the stepper motor over here, you can see the rotor. Okay, rotor not with single north and south poles, Rotor is actually having multiple poles, wherein alternately north and south poles are there on the rotor. And when it comes to the windings of the poles on the stator, as we have seen in the magnetic case, opposite windings have been shorted. See, there is a connection that is actually passing through, that is trying to connect BB dash. Similarly, AA dash. Maybe right now in this particular location, when you notice properly, north and south of this particular one, north and south of A phase are actually in line. Okay, so maybe when you this may be the situation whenever A was excited. If you excite B, what happens? So this entire south will not come here. The adjacent south will come to this. This is how we will be able to reduce the step size. Okay. Anyway, let us see what has been stated here. The teeth are made up of soft steel and two sections of which on each pole are misaligned each other by a half tooth pitch. This is what is that. See, these two sets are actually misaligned. Okay, and this motor works similar to that of permanent magnet stepper motor. Figure shows two phase. So you have got phase A and phase B, four pole. Okay, and the 6-tooth rotor hybrid stepper motor. When the phase AA dash is excited with a DC supply, the rotor aligns such that the south pole of the rotor faces the north pole. Means unlike poles are going to be attracted and like poles are going to be repelled, that attraction force is going to contribute towards the rotation of the rotor. Okay. Anyway, once you know the principle of its operation for one motor, same is going to be the principle of operation for everything. Anyway, the other things you can maybe one particular point for every excitation, rotor will get locked into new position, and even if excitation is removed, motor still remains its locked condition due to the permanent magnet excitation. So the advantage of the presence of permanent magnet excitation is actually the presence of that is going to continue its attractive force, or maybe its locked condition in spite of the excitation was removed. Means that when there is no supply either for the phase A dash as well as for the phase BB dash, so the self-excitation of permanent magnet ensures that the rotor will never be permitted to rotate. That is what has been stated. Anyway, in the permanent motor, permanent magnet type, the step angle was observed to be 90 degrees. Now here, the combination of permanent and variable reluctance is actually hybrid, wherein it is associated with the one what we have considered is associated with two-phase, four-pole and six-tooth rotor motor. Now the number of phases and number of tooth on the rotor. Whatever the expression what we have considered earlier, same expression still holds good even in this location, 360 by 2 into 6, which is equal to 30 degrees. Now for higher angular resolution, means if you want to reduce this step angle further, hybrid motors are constructed with more number of rotor poles. Means if you go on increasing this particular 6 number, maybe 6 by 12, in place of 6 if you put 12, then the step angle size will come down to 15. If you raise that to 18, 30 by 3, the step angle will come down to 10. Likewise, more and more the number of poles you go on, tooths you go on considering on the rotor, the step angle with which the movement of the rotor can be regulated is going to go on come down. Okay. So what you should understand was earlier at the time of specifications, we have noticed that what is the accuracy we want to achieve, and what are the minimum, what are the displacements, what all you need to, what might be the work volume you need to handle. Is that going to be on par with the Cartesian or polar or spherical? All those requirements you should state. So now at the time of stating, if you doesn't state your requirement properly, you can see here the step angle, once it has been fixed with the number of tooth on rotor, it is though we are intended to get much more smaller step value, it is not possible. So if you want to make it possible, that entire motor which we have procured earlier had to be replaced. Okay. So that is the reason at the time of putting an order with a particular specification, we are supposed to be very, very careful and observe all, keep in mind all the aspects, and only we are supposed to proceed. Okay. So anyway, prior planning is essentially required for any sort of success you are aiming at. Okay. So anyway, let us see what has been stated over here. At standstill position, the motor has full torque. This is basically because of permanent magnet availability. No matter if there is no moment or changing position. That means in the standstill position itself, you are talking about that time when there is full torque, in the sense if you try to move by manual means, you cannot, unless otherwise you push that particular unit with higher amount of torque, whatever the torque it is trying to exert. That might spoil the motor. Okay, so that is what is actually. Then it has a good response to starting, stopping, and reversing positions. So means the moment you wanted to start, it is going to start. The moment you wanted to stop, it is going to stop. The moment you have instructed that to go back in the reverse direction, it is ready to. Okay. It is reliable and life depends on the bearings of the motor. So that too, there are no contact brushes. So brush, till now we have not taken into account the presence of brushes. Maybe brushed motor we have seen. There will be some lifespan for that particular brush, maybe 2000 working hours or 20,000 working hours or like that. So after that particular span, brushes will not maintain contact with the commutator. Because of that, even if you ensure that the power supply is going on, since there is no contact between the brush and the commutator, the power will not reach the rotor. Okay, uh, that is how the lifespan is actually trying to provide some restriction on the motor functioning with the presence of brushes. Since there are no brushes present over here, its lifespan is comfortable and reliable, provided the bearings, whatever you are trying to use, they should be with good quality, or the bearings life should be kept in mind, and based on that, you need to go for replacement of those bearings at appropriate locations. The motor rotation angle is directly proportional to the input signal. Anyway, this in some other respect we have already seen. More voltage you supply, more RPM, revolutions per minute you are able to attain. So something like that. On the similar grounds, this particular fourth point is, it is simple and less costly to control as motor provides open loop control. So once you are having an open loop, in the sense there will be no feedback signal, means we will not have any scope to compare the input signal. Normally it is going to be referred as reference signal, which is the output signal. Okay, so because you are trying to regulate in terms of step angle, so because of that, we doesn't need any feedback signal. So once there is no feedback signal, some devices, what all you are trying to put, rather the sensor, you name it as a sensor, the presence of sensor itself is not going to be there. So because of that reason, it's going to be a bit lesser with respect to the price. Since the motor is okay, this is actually just you can couple directly from there. The exact positioning and repeatability of movement is reasonably good, as its accuracy is 3 to 5 degrees, sorry, 3 to 5% per step, and it is not cumulative. That is another important point. See, each and every step it is receiving a pulse, and in each and every step, 3 to 5 degrees error is going to be there. Means 0.03 to 0.05 variation hardly is going to be expected. Okay, in terms of percentages is going to be expected. That too, that error is not cumulative. In some situations, what happens is, once an error has occurred at stage 1, that error is going to result, based on that particular error, the total result is going to be seriously affected. Whereas here, it is not going to be. For each and every step, that has been confined to 3 to 5%. Say step 1 is confined to this, step 2 is confined to this. Step 1, whatever has happened error, that error will not come onto the step 2. Okay. These motors have high torque at low speeds, and these are very reliable in simple construction. This particular point has come already above, and even the last but one point, high torque, it has come at low speeds. Comparison between torque and speed has come over here. Rather than I was trying to point out that better you try to go through the torque versus speed graphs. Then some disadvantages will be there in spite of having so many advantages. These disadvantages and advantages are being represented, uh, keeping in mind that the other two, like the advantages with respect to the other two and the disadvantages are also with respect to the other two. It's going to be okay. Stepper motors having low efficiency. It has low accuracy. See, contradictory statements have come because earlier we have been stated that this is actually having a good repeatability and accuracy. Now here they are trying to state that it has low accuracy. That low accuracy may be because of the open loop circuit, or maybe with respect to the comparisons being made with one of those two might be. Okay. Its torque declines very quickly with speed. So at low speeds, no doubt it has been observed that it is having high torque, but when the speed rises, automatically the torque declination or decreasing trend with respect to the torque, or the rate of decrease of torque when you try to refer with respect to the rate with which the speed is rising, that rate of torque being declined or decreasing is noticed to be very, very high with respect to the other two. As stepper motor operates in open loop, there is no feedback. That is obvious. Once there is no feedback, we will never be in a position to understand what has happened really. It is something like I can always give some comparison. Say, as a student, you are trying to evaluate your teachers at the maybe in between the semester or at the end of the semester, quoting some specifications. You might not be taking those aspects at the time of evaluating so seriously, but we are going to get all those feedback to us. Maybe at times we may be harsh, and that is going to be reflected in your feedback. And based on that, we will try to make some corrections on it. So likewise, I can give you some other example from student point of view also. These examples I'm trying to use so that we are all practically experiencing. Say you would have written an examination, and there is a evaluation system, and you following that particular evaluation system. Some people may get failed, some people may get passed, and some people may get pretty good marks, and some people may maybe with respect to the batches performance, when it has been taken into account, some people might be performing extraordinarily. How that has been measured? If you doesn't, there is no other mechanism to measure your performances other than conducting the experiment. That is a sort of feedback information. Something like this, even here, you are giving an input signal and you are expecting an output, and without having a proper measurement on the output, whatever has been done against the input, we doesn't know what has been done over there. So that is one among the feedback, maybe that is one among the drawbacks. Sometimes there may be some steps that might be missing, maybe on its repeated usage. We may miss some steps, and we will never be in a position to quantify them. Anyway, they are noisy. So at the time of its operation, we found them that they are making a lot of noise. Some applications, when you try to see over here in manufacturing sector and in security devices, in manufacturing sector, like automated production equipment and automotive gauges and industrial machines like packaging, labeling, filling and cutting. You may notice these applications are so simple: packaging, labeling, filling and cutting. So the pace with which they can finish those tasks are incomparable with the pace with which a human can manage those issues, because they deliver those jobs without experiencing any what do you call they'll not feel any discomfort, even in spite of they have been put on work for many hours, that too in a continuous basis. It is not the case with respect to the human being. Let us see now, if you want me to speak hours together, sir, ಅದು ನಿನ್ನ ಪ್ರಯತ್ನ ಆಗಲ್ಲ. If you anyway, if you try to take those parameters into account, the performance wise it is actually incomparable, because it doesn't need any rest. So for example, if you want me to speak continuously for 18 hours or 20 hours, maybe for 2 hours or 3 hours, at this age I may be able to. Maybe at an younger age I would be convenient to speak for about 5 hours or so, of course. So that too, the performance with which I might start or I might continue today, if you measure it with the performance of tomorrow, it might vary. It is not going to be exactly on par with the performances of day one, day two, or hour one, hour two, hour three, likewise. Whereas that is not the case with respect to the robo sector. Okay, so they will be able to perform however they were performing today, with the same performance they will be able to perform tomorrow or day after tomorrow, this hour, next hour, or next hour. So continuously they can be put in operation for a span of 18 hours or so, unless otherwise the devices or the parts whichever has been put in use for preparing that or manufacturing that is actually coping up. Then of course, security and security devices, when you try to, you have got surveillance cameras and security things. They may appear to be so simple, but when they have been given some prior conditions, like taking that particular vision sensor, it is going to take a decision to permit you or not into a particular room or into a particular hall or not. Okay, something like that. You can go on extending your decisions on those grounds. Okay, then not only that particular thing, maybe some parts are going to be inspected, some manufactured parts are going to be inspected with the support of non-destructive testing. Normally what we do is, in our laboratory we try to take a particular metal piece to the what do you call strength of materials lab, wherein we try to conduct some test, hazard impact test or something. We break the piece and we shall try to decide what is exactly its strength or whatever it is, tensile strength, compression strength, rather in a simple way mechanical properties. Whereas when you go for non-destructive testing, you don't have to really spoil the piece. You are going to send some beams, laser beams or some kind of beam are going to be sent. Through that, you will be able to get the exact structure of that particular piece, and we will be able to get straight away what all its strengths and all. Okay, so these are all can be interfaced under this particular category. And when you go to the medical industry for digital dental photography, respirators, fluid pumps, blood analysis machinery, and medical scanners, etc., all these things are all going to come under this particular category. Okay, so these are all trying to make use of these stepper motors. And in consumer electronics, for image scanners, photocopier and printing machines, and in digital camera for automatic zoom and focus functions and positions. Not only that, even 3D printer, you name. So many more applications are there, which we might be using them without our knowledge, and we will not be in a position to understand unless otherwise we give a serious thought onto that. So as a student, you will be really in a position to learn whenever you come across a certain situations. You should go on thinking in depth about that particular situation, like why it is like this, what is in this, why it is behaving like this. This is the important. This is how an engineering student can analyze, make self-analysis, and grow. See, I will tell you a few examples, though I might be going beyond my topics. It is something like today you are having so many skill training programs. Prior to this, the technology was there. Maybe Fortran 7 was there, Fortran 4 was there, and even basic language was there, COBOL language was there. No training institute was there to train on those languages. Unix platform was there, only DOS environment was there. Even if you want to open a file and delete a file and do some, maybe if you want to move your cursor from the existing position to the upper line and lower line, for each and every movement of your cursor and for any selection, whatever you are trying to do with a simple mouse operation, for everything you need to memorize a command. There was no training institute those days, but still people used to learn, follow, implement all those things. This is all happened because they have the major advantage of observing and learning the grabbing the contents. Okay. Okay, so nature is actually proved to be the major content, using looking at which we all can learn many aspects whatever we doesn't know today. Anyway, stepper motors are also used in elevators, conveyor belts, and lane diverters. Now let us move to the servo motor. Servo motor is an electrical device that rotates parts of machine with high efficiency and great precision. So the first statement itself is trying to give its advantages with respect to the precision and efficiency. The moment it has been given, it indicates that it has been compared, its performance was compared with the available motors. Maybe at the time of inventing that particular servo motor, which are the motors that are all available, all those motors have been taken into account for comparison. With reference to that only, this particular statement would have been issued. And the servo motor would be of DC or AC, and they can be used to push by a specific distance, or they can also be used to rotate an object by a specific angle with great precision. It is a simple motor which runs through servo mechanism. What is the servo mechanism? We will see if time permits. Okay. So one particular aspect what you should keep in your mind was servo motors will be making use of or taking the support of servo mechanism to control its motion. It could be linear motion or it could be rotary motion. Okay. So the servo mechanism might be as an integral part of that particular motor. It might even happen on those grounds. Let us see, if possible, let us see in the forthcoming slides. And of course, it is quite possible to get high torques. Okay, that too, when you are aiming at high torque motors, we may get an impression that the motor size might be more, and even the weight of it might be more, but it is reverse in this particular respect. So it is possible to get these servo motors in smaller in size with the lightweight, but still it is possible to get high torque motors. Okay, so normally the servo motors are going to have a rotary actuator that is allowing. Precise is actually the word which has already come. So that precision is trying to give us give us a scope to satisfy certain parameters. What are those parameters? You might be aimed at positioning your actuator with respect to the angular matter, or it might be with respect to the velocity. It might even be with respect to the acceleration. Anyway, you may look at these three contents on different aspects, but all these three are interdependent. Something like once you know the relative movement with respect to time aspects, when you try to take into account, that is going to give us a total clear-cut idea on the velocity. Then the rate with which it has been taken into account, then we are going to get the considerations of acceleration. So though these three things have been listed out as a separate event, so the sensor, whatever you are trying to attach to that, is going to give us the time that it is trying to take to move from point 1 to point 2, and the rate with which that particular span is trying to move from between different points. All those aspects are going to be sensed. So when that has been sensed and observed, it has been noticed that servo motor is actually having pretty good control with the with the satisfied precision requirement, with satisfied the requirements of precision in attaining these three, in satisfying these three quantities: position, acceleration, and velocity. Okay, then it has certain capabilities that a regular motor doesn't have. What are they? He's trying to put us an interesting aspect over here. I don't know what is that. Let us see. Consequently, it makes use of a regular motor and pairs it with a sensor for position feedback. See, that is the beauty of it. See, a regular motor will not have any sensor, whereas this one is going to have a built-in sensor mechanism. Like motor is going to be paired with sensor. So once these two are paired, we are going to get the feedback for a particular input. What exactly is the output it has really given? We are able to sense that information straight away from that. It is something like it is something like suppose if suppose I am trying to take a feedback for each and every session. Say session one, taking the feedback on that. Session two, taking a feedback on that. How does it helpful? Maybe in session one, few contents I will be covering. So I will be getting your feedback and your extent of understanding exactly what has happened on that particular session. I will be receiving as an input on that particular session. The moment I have received feedback on that particular session, what happens is I will be able to rectify the pitfalls, whatever has been noticed, is for the next slot. So that continuous feedback I can take, continuous pitfalls I can notice, and continuously I can try to apply the changes what all I can, so that maybe in a midway through, maybe after 10 sessions or 15 sessions, I might tune to you, or either I might be tuning to you or you might be tuning to me. Perfect tuning will happen, provided when does that happen properly? So when you are giving the feedback properly, and when I am receiving your feedback on general grounds, and when I put sincere efforts to rectify those what you call when I do those corrections wherever required from my side. So commitment should be there from your side as well as from my side. Okay. Anyway,
Excuse me, sir.
please. Are
Sir,
we
it's
crossing
around
our time?
9. It's around 9:45.
Okay, okay, I'll stop. I'm sorry. You can give me a warning at 9:40. Okay, 9:40. If not
Okay, sir.
9:42 at the most. Don't don't pull me to that extent. Okay. Anyway, thank you for alarming me. That's good. 1 second. I'll stop recording. Then I will take attendance.